Hello everyone. Today we are solving a DSA problem expression add operators where we have been given a number a string which has digits, and we have these binary operators plus, minus and multiplication. We need to add these operators in between these digits and evaluate the expression to match the target value 6. For example, let's say we have 1 plus 2 plus 3, which evaluates to the 6. So this is the valid expression. Then we have 1 into 2 into 3, which evaluates to the 6. Again, it's a valid expression. We have 1 into 2 plus 3, which evaluates to the 5, so which is not a valid expression. So we need to return all such expressions. Let's take another one example. We have 2 3 2 and target value is 8. So if we add 2 plus 3 plus 2, it is 7. So this is not a valid expression. Then 2 plus 2 into 3 plus 2, the value is 8. So this is the valid expression. Again 2 plus 3 into 2. So 3 into 2 is 6 plus 2 is 8. So this is also valid expression. So we need to return such valid expressions. So to solve this problem, we have three steps basically. The first step is we need to find all expressions for given string, and we need to evaluate each expression to match the target value, and if match, then we need to return that expression or we need to increase the count. How to find the expressions first? So let's say we have string 1 2 3 and we have these operators plus, minus and multiplication. So let's say we have this digit 1. So how many operators we can add? So we can add plus 2, minus 2, and multiply by 2. Then after 2 we have 3. So how many operations we can perform with 3? Plus 3, minus 3 and multiply by 3. For this, how many operations we can perform? 3 plus 3 minus 3 and multiply by 3. Same here, after 1 into 2, how many operations we can perform? We can perform 3 operations plus, minus and multiplication. So total how many operations are there? There are total 9 expressions. Now we find out the expressions, total expressions using tree. So now we need to evaluate the expression. So how do we evaluate the expression? The first is 1. Okay. Then go to the 2. So we follow this path and the value is now become 1 plus 2 is 3. Okay, 1 plus 2. Then 2 to 3. So 3 plus 3 is 6. Okay, so plus 3 is 6. Now there is no child, so we will backtrack it. Again from here 1 plus 2 we have the value is 3 and 3 minus 3, it is 0. Then again the childs are null, so we will backtrack. Now there is multiply by 3. So now 1 plus 2 into 3. So what happens here? We need to multiply 2 into 3 first and then add the 1 later. We need to do, we need to 3 minus this 2 plus then 2 into 3. So it will be 1 plus 2 into 3 is 6. Okay, so the value is become 7. Same, we will evaluate each and every expression from this tree, and if it evaluates to 6, the target value 6, then we will return that expression. Or let's understand what is the time and space complexity of this algorithm. Now the time complexity, so how do we calculate the time complexity here? So here we have these three operators. So each node will have three child nodes, and we have number of digits are 3. So here we have 3 raised to 3, means if so this 3 is fixed and this will be vary, so 3 raised to n. So for this program the time complexity will be 3 big O of 3 raised to n. And space complexity, so we are using backtracking. So backtracking will be done by using recursion. So for recursion we will use stack, and the space complexity of stack is the height of a tree, and the height of a tree is nothing but the number of digits in string. So the space complexity will be O of n, where n is the number of digits in string.
Now program for this. So we have function backtrack, okay, where we will accept num, then target, then current index, then operand, then current value, okay. And what we'll do, first base condition, if index is equal to num dot length, means we have reached to the leaf node. Then check if the current value matches to the target, then return 1 to increase the count, otherwise 0. Next, now we need to do backtracking here. So the first function call recursion backtracking. First we need to find the current digit. So integer digit equals to num of index minus 0. So num of index is character, so character minus 0 we will get the digit. So in first we'll use the addition. So here num as it is, then target as it is, then index plus 1, then last operand is digit, and then the current value is, now current value will be current value plus the digit. This is for addition. The next is for subtraction. So num as it is, target, then index plus 1, then we have digit minus digit, last operand, and then the current value minus digit. Then next is for multiplication. So backtracking num target index plus 1, then the last operand is operand into digit, and the current value will be operand plus last operand into digit. So this will be the multiplication formula, and finally we will return the count. So count will be here, count plus so every time we will increase the count, and here count. Okay, anything missing? Okay, fine. So backtracking num target index last operand current value, then if index equals to num dot length, that is, this is the base condition, so where we are returning 1 or 0, and after returning 1 we'll add it to the count. If it is 0, then we will add into count.